Right, so for the video today, we are going to discuss, for this video, we are going to discuss the mode, mean, and also the variance for Poisson distribution. Right, so in the previous video, we already learned how to identify the Poisson distribution and also how to apply the formula to get the probability for Poisson distribution. Alright, so all those make sure that you already know how to apply the formula. And now we are going to further to discuss the mean, variance, and mode for Poisson. Alright, so learning outcome 1.2, you need to know that mean and variance of Poisson distribution are actually equals to mean. Okay, so now for Poisson distribution, you need to know that mean is lambda, the variance is also lambda. So the mean and variance of the Poisson distribution are equal. So you have to remember this. Alright, so it's a very special distribution because the mean and variance are having the same value. So that's why it's called as Poisson. Alright, and then just to recall back for binomial. If let's say you're having a binomial distribution, what is the mean? Okay, so the mean is MP, right? And then the variance is MPQ. Okay, then for geometric distribution, alright, so what is the mean? If I'm not mistaken, it's 1 over P, right? Is it? Okay, and then variance for geometric distribution is not covered in our syllabus. Okay, then now you go for the third one, Poisson. So Poisson is having the same mean and variance, which is lambda. Yeah, right. Then now, how about the mode? Okay, so the mode is actually the value of x that is most likely to occur. That means is having the highest probability to occur one. So that's the mode. Okay, then in general, there's a short summary about how you can decide the mode. Okay, in general, when lambda is a whole number, then there are two modes here, lambda minus 1 and lambda. So as an example, if let's say I tell you that x is Poisson distributed with, let's say 5. It is a whole number, right? So what is the mode for this Poisson distribution? Generally 4 and also 5 are both the modes for Poisson distribution, lambda minus 1 and lambda. Okay, then now if let's say your Poisson distribution, the lambda is not a integer, a whole number. Okay, so let's say x is Poisson distributed maybe with 7.8, let's say. So the mode is the next whole number below lambda. So below lambda means that, okay, this is your lambda 7.8, right? So what is the whole number below lambda? It is actually 7. Alright, so maybe some of you will ask me that, I thought Poisson distribution is discrete random variable. Can I have the mean with decimal number or not? Alright, so just to clarify, in discrete random variable, the mean can be any number. Not necessarily must be whole number. Whole number means that when you want to find the probability for x equals to something, so all this must be whole number. Okay, but for mean and variance, it can be decimal places, right, for the answer. Understand or not? So the discrete random variable means that x must be integer, or mostly they are integers when you calculate the probability for the value of x, like x equals to 3, x equals to 5, and so on. Right, so this is just to clarify maybe some of you will feel confused. You thought that the mean must be also integer. No. Okay, so here, knowledge of the mode will not be needed in the examination. So generally for mode, they are not covered in the examination. But the exercise that I provide you later to try out, they actually ask this. So better I cover this first, okay, to let you know. Alright, okay, so main thing, again, summary, you need to know that the mean and variance for the Poisson distribution are the same, which is lambda. So this is the most the important part that you need to know. Okay, let's have a look for example 4. How are we going to try all the questions related to this one? Alright, so now example 4, x follow a Poisson distribution with this standard deviation. Find x greater equals to 3. Okay, so again, since you know that standard deviation is 1.5, so what is the variance? So the variance will be 1.5 square, right? And then you should get 2.25. So for Poisson distribution, you know that mean is equal to variance, which is also 2.2. So this is the knowledge that you should know. You should remember actually. Okay, then from here you know that x is Poisson distribution with the mean 2.25, and they want you to calculate x greater equals to 3. So again, I'm not going to show you the detail of the steps. If you try out correctly, you should get the answer 0.391. This I'll just leave it for you to complete it. Right, so now continue with example 5. Okay, so for example 5, they are talking about the number of accidents per day. So again, you see the per day is the interval, right? So that's why from here I know that it's Poisson. And this question already tell you clearly it is Poisson distributed with parameter 2.25. So the parameter 2.25 means this is the lambda. Okay, so state the mean and standard deviation of the number of accidents per day. So very easy, no? Mean is lambda, right? So mean is equals to 2.25 lah. Alright, so what is the standard deviation? So the standard deviation will be square root of 2.25 because variance is also 2.25. Therefore, to find the standard deviation, you square root it and you will get 1.5. This one very simple, nothing special. You just apply the knowledge that you memorized just now. Okay, then now you go for example part 2, 5.2. On how many days in November would you expect the number of accidents to be within one standard deviation of the mean? Okay, so this is something not so straightforward. Okay. They want to know the number of accidents. So number of accidents is actually x, so the discrete random variable that we are going to find out. Because here they said the number of accidents per day, so you can assume that it is x. Okay, so the number of accident is the x within one standard deviation of the mean. Okay, so one standard deviation of the mean within one standard deviation of the mean means that mean minus standard deviation, one standard deviation, or mean plus one standard deviation. So this is the meaning of within one standard deviation of the mean. Okay, so that means the distance between the mean and also the x, how should I explain it? It should be something like one standard deviation away from the mean. So when we are having mean, okay, wait, my file is auto-saving and it is not responding, so I cannot write anything now. So please wait for a while. Okay, so that means when you're having mean, right, one standard deviation of the mean means that one standard deviation away from the mean. So that means you can have this, one standard deviation, or away means that you can have also like this. So if let's say it is before, standard deviation before the mean, so this one will be mu minus standard deviation. Then for this one, it will be mu plus standard deviation. So both also have the same meaning as one standard deviation of the mean. That means away from the mean. Okay, so that means the number of accidents should be between these two values. So what is the smaller value? So mu minus standard deviation, and then the larger value is mu plus standard deviation. So to get the expected number, before you get the expected number in November, what you need to do now is you have to find out the probability first. After you find the probability, only you multiply total days in November to get the number of days. Alright, so now let us start. The mean that you get just now is 2.25. Standard deviation is 1.5. Smaller than x, smaller than 2.25 plus 1.5. So if you simplify the values here, you will get 0.75 until 3.75. Okay, every time when you look like this, don't always assume that you need to use the normal distribution table to find out. Again, please remind yourself, we are now solving the Poisson distribution. So for Poisson distribution, x can take the value integer only. So what are the integer between 0.75 until 3.75? So you can have x equals to 1, x equals, and also x equals to 3. Alright, so to calculate the probability for this 3 is E negative lambda. Then x equals to 1 is lambda 2.25 plus 2.25 power 2 divided by 2 factorial. And then 2.25 power 3 divided by 3 factorial. And then by using calculator, of course, you can get the answer easily, which is 0.704. So this is the probability that x between these two numbers. But they're asking for how many days in November. They want to know the number of days. They don't want the probability. So to know the number of days means that you need to take 0.704 multiply with 30. In November, there are 30 days, right? And approximately you have 21.12 days in November. The number of accidents is between these two values. Okay, so if you want, you can keep it as 21.1 days. For me, I will just write out 21.1, 3 significant figure. And then some students will ask, hey, the number of days, I thought I need to round up. That means in the integer. Okay, so for your information, this value actually is an estimation. So for estimation, it is still valid if you write it out in decimal place. Okay, so the number of days here, although it's 21.1 days, but generally, it is just an estimation, so you still accept this answer. Some students want to change it become 21 or 22. Actually, to me, I don't really suggest you to change it or round it up or round it down. I will still ask you to keep it into 3 significant figures. Okay, so this is what we have for our answer here. 21.1 days in November. Okay, we'll have the number of accidents between 0.75 and 3.75. So that's the meaning of this question. Okay, so actually this part 2, they are mainly test you on understanding the sentence itself. I understand that a lot of students won't able to write out this one. So you need to know what is the meaning of within one standard deviation of the mean. So this is the mean. Okay, alright, so this is what we want to cover for the mean and also the variance for Poisson distribution. Alright, and for the next video, we are going to learn how to apply Poisson distribution in the real life question, in the more application type questions. Okay, for these two videos, the previous one and also this one, mainly we are just learning all the basics, all the probability, the formula, okay, and also the mean and variance. All those are very basic ones. Then now we want to use all the knowledge, right, to apply in application questions. So we'll discuss all this in the next video.